Hey everybody, welcome back for some stats action. We're going to be looking at the Chapter 8 practice test, which is estimating with confidence. It is our section, our chapter, on confidence intervals. We have the effect of acid rain upon a yield of crops is of concern in many places. In order to determine baseline yields, a sample of 13 fields was selected, and the yield of barley in grams per 400 meters squared was determined. The output from SAS appears below. So SAS is a software, computer software, that calculates statistical things for you. And there are only a few things from this output which are really important to us. First, we have the mean of the sample and the standard deviation of the sample. And we also have the sample size. In a question like this, we're really just looking to get the confidence interval. We're not trying to construct this with all of the four-step plan. So we're taking the easiest approach to how to calculate this. In essence, we're just doing the do part of the four-step plan, if you remember do. So the first thing is a general formula for any confidence interval. That's a point estimate plus a margin of error. The specific formula is x bar plus and minus t star s over square root n. Our next job is to substitute the values. So my x bar is 220.231 plus and minus t star, which I'm going to leave for later, and then s over square root n. Well, that's going to be 58.5721 over the square root of 13. Now let's talk about this t star, and there's going to be a couple different ways that we're going to get this t star that I'm going to show you. Now the first way is going to be if you are in a calculator classroom and you do have access to a TI-84, you're going to go ahead and use your TI-84. So in order to get this, we're going to go to distribution. We're going to go to inverse t. And for the area, we're going to have to know the confidence level. So I'm taking a peek, and our confidence level is 0.9. So the area we want would be half of the tail area. If we're going to draw a normal distribution, and I'm going to exaggerate this a little bit, but if we're going to draw a normal distribution, we would put a 90% in the center. That's our confidence level. And then these two tails together have to make up the remainder of the area. So in essence, it's going to be half of 1 minus 0.9 on either side of those. Now when we get to our calculator, we're just going to put that literally into our calculator. So half of 1 minus 0.9. Yes, I know it's 0.05, but if you want to save yourself a little bit of headache, you might want to do it this way. Or if you think it's easier to just put a 0.05, just put a 0.05. You're not going to hurt my feelings. Degree of freedom is 1 less than the sample size, and since the sample size was 13, our degree of freedom is 12. Let's paste that and push enter. We're going to get a t star of 1.782. Even though my calculator told me negative, t star is always positive, and while we're on the subject, t star and z star are both always rounded to 3 decimal places. So let's just go ahead and substitute in over here. And then we'll just multiply out that margin of error. And our margin of error will be 29.9486. Now another way that you might choose to get that t star is to use a web app. And the one that I'm going to use is going to be Statology Inverse T Distribution Calculator. Let's go over to that real quick. And for this, you just have to enter in a degree of freedom. I think we are at 12. And then we needed to enter in our confidence level, and we're at a 90% confidence level. Calculate, and over here it tells me the T star, that's 1.782. It gives me one more decimal place than I really need, so just make sure you round that, 1.782. Which was, of course, the same thing we got from the TI calculator. So it's totally up to you how you want to figure out your T stars. I think the web is actually a little bit easier here. For our problem number 2, you want to compute a 90% confidence interval for the mean of a population with an unknown population standard deviation. That's kind of normal, actually. So the sample size is 30. What value of t should we use? And since we've already gone over using the TI calculator, I'm going to go back to Statology and enter in that information. We've got a 90% confidence interval, and our degree of freedom is 29, so let's put a 29 in there. And calculate 1.699. And that's going to do it for our answer here. We'll just include a couple of screenshots here so that we know how we got that T star. So, number 3, to assess the accuracy of a laboratory scale, a standard weight that's known to be 1 gram is repeatedly weighed n times, and the mean is computed. Suppose the scale readings are normally distributed with a mean of mu and a standard deviation of 0.01. How large should n be so that a 95% confidence interval for mu has a margin of error of 0.0001 question mark, and then also an interval width of 0.0003. So this is 2 questions, really. First thing we should know is that the margin of error is actually half of the width, but the margin of error is the thing that we're usually going to see on our calculations or our formulas. So really early in this practice test, we're coming across one of the really big contradictions. I guess it's a good contradiction. But when you're calculating for sample size, you have to use Z star. There really is no other way, because T star is dependent on sample size, and of course you don't know sample size, so you got to use Z star. The formula for margin of error is Z star multiplied by sigma over root n. And we better go over getting our Z star. So we're going to do something very similar, except for we're going to use inverse normal. Our area is 1/2 of 1 minus our confidence level. And we're going to keep sigma mu 0 and sigma 1, and we're going to paste that to get our Z star. So 1.96. Of course, for Z star, you're supposed to, or 1.96 is one of those values that most people will memorize. So we'll just substitute that 1.96 into our formula. While we're at it, we're also being told that the margin of error is 0.0001. And we are also told that sigma is 0.01. So really we have everything we need to solve for this sample size. Grab your calculator, head on over to the solver, and we'll substitute the left side of the equation, 0.0001, and then on the right side of the equation, looks like we're almost correct here. There we go. We'll scroll down and we will take a guess. Now I always start my guesses like 1,000, and I'll push alpha and then enter. It looks like I needed to put a multiplication sign here. Okay, that'll do it. Let's try this again. Alpha and then enter. There we go. 3,000 38,416. And of course, we're probably going to want to round that up. So there we go with our sample size. If this is a multiple choice test, just do the one that's closest to it. For the second part of this question now, the margin of error is half of the interval width. So we're just going to do half of, and I really am just going to do 0.0003 divided by 2. Z star is still 1.96. Sigma is still 0.01. And now we can put this into our solver. Scroll back up and change this to 0.0003 divided by 2. Because the margin of error is half of the interval width. And then we're good to keep going with that same guess. Although, you know what? I'm going to go back to 1,000. I just feel like starting at 1,000. So now that the cursor is in the right place, I'm going to push alpha and then enter. Just like last time, make sure you round up for your sample size. And I will see you on the next video when we look at more of the practice test for confidence intervals. See you later.